On a laser marking system, the coherent light beam is directed through mirrors moved by systems known as galvanometers. This beam passes through a focusing lens whose characteristics allow the laser to be focused on a plane parallel to the lens. The lens deforms the single laser beam, changing it from a cylindrical shape to a cone shape, the ideal vertex of which falls on a plane parallel to the plane of the lens, regardless of the exit angle of the lens. If you approach the ideal vertex of the cone, you can see the point at which the maximum power of the laser beam is concentrated in the smallest possible area. The plane where this point is located, i.e. where the laser vertex falls, is called the focal plane. In reality, the laser beam is not concentrated at a point such as the vertex of the cone, but has a zone in which the beam has a minimum cross-sectional area. In practice, this translates into a focal distance, or working distance of the laser, which is subject to a certain tolerance, called the depth of field. The depth of field, in turn, depends on the focal number of the lens, as well as the starting laser beam itself. So basically, any lens with a different focal length has a different depth of field. For example, if an f160 lens has a depth of field of 1.5 millimeters, an FFL254 focal length lens will have a depth of field of 3 millimeters. These are illustrative values, more or less susceptible to variation, with the material to be marked. The more acute the angle of the ideal cone vertex, the more the tolerance increases, and the greater the minimum spot of the laser beam, producing a different effect on the marking. When the laser beam impacts the material perpendicularly, there will be a higher efficiency of energy transmitted to the material than if it were to impact at an angle. For this reason, the marking area is limited so as to preserve an acceptable angle of impact. The focal lens makes it possible to have different marking areas by varying the focusing distance. The marking area will be greater as the focal distance increases. For example, if a f160 lens allows a focal distance of 220 millimeters and will have a marking area of 100 by 100 millimeters with a circle with a diameter of approximately 141 millimeters at the same angle of impact, a 254 lens at a focal distance of 330 millimeters will allow a marking area of 160 by 160 millimeters with a circle with a diameter of approximately 226 millimeters.